All right, welcome back. We're going to keep going. Lesson 66 is finding perimeters and areas of regular polygons. Okay, first off, let's review what does it mean to be regular? Okay, we've done regular shapes before. What does it mean? That's right, they have the same angles or congruent angles, same angles, and same sides. I might put the word congruent sides or congruent angles. Okay, that's what it means to be regular. So we're going to talk about polygons, triangles, squares. Right? Triangles it would be more specific to equilateral triangles. Okay, but I'm going to do one a little bit different. I'm going to do a pentagon. A pentagon has 5 sides. Okay, if this is a regular pentagon, every side length is the same and every angle is the same measure. Okay? One thing we need to notice about regular polygons, or really any, well, not any, but in a regular polygon, we'll have a center. Okay? So the center, I'm going to put a C there. The center of a regular polygon will be equidistant. Means equal distance from every angle, from every vertex. Equidistance from every vertex. I'm going to go ahead and say vertex. Okay, so from the point C to this vertex will be the exact same length from this C, from C to that vertex. Kind of like the radius of a circle. Okay, this creates in the center what we call a central angle. You might recognize that from circles. So we kind of are relating this a little bit to circles, like this is a radius. Okay, so we're talking about the center and the central angle. Of a regular. I'm going to have to put this because you can have central angles of circles, and now we have a central angle of a regular polygon. Okay, so what is the central angle of a regular polygon? It's the angle whose vertex is the center of the regular polygon and whose sides pass through consecutive vertices. Okay, I'm not going to say all of that. Kind of paraphrase it. Angle whose vertex is at the center. And the sides are consecutive. So that just means beside. Consecutive vertices. Okay? So like we've drawn, here's consecutive vertices. So this angle right here would be a central angle. Okay? One more definition that we need to write is called an apothem. Okay, an apothem is special to a regular polygon. Okay, it says it will be the perpendicular distance from the center to a side of a regular polygon. I don't know if you've noticed yet, but regular polygon is kind of important in this lesson. We will not be finding these perimeters and areas if they're not regular polygons. Okay, so you may ask, what is an apothem? That's the perpendicular distance from the center to a side. So we have to go from the center to a side perpendicularly. Okay, that will be the apothem, or the height. Let's go ahead and say that. It's going to be the height of this triangle. Okay? So, let's keep going. If you have a regular, any type of shape. Okay, let's go ahead and move on. Let's talk about a regular hexagon. Pretending this is a regular hexagon. And if I tell you it's a regular hexagon, then I don't need to draw the angles and sides the same. Okay? I tell you it's regular, they all should be the same. Regular hexagon with a side that measures, let's just say 4 centimeters. Okay? What is the perimeter? Okay? Pretty simple. You still have to know how many sides does a hexagon have if it's not drawn here for you. Okay? Hexagon has 6 sides. Pentagons have 5. Octagons have 8. Heptagons have 7. Go back and look at that. So, what would the perimeter be? Well, I might have to go look and say, well, this is 4 centimeters, this is 4 centimeters, and 4 centimeters. Every side is 4 centimeters, so I would take 6 sides times 4 centimeters apiece, and I would say the perimeter is 24 centimeters. Pretty simple. Perimeter is not going to be that hard because every side has to be the same. You just have to know how many sides does each one have. Okay? If I say, what's the side length? What's the perimeter of a decagon? Okay, new problem. What's the perimeter of a decagon with sides of 2.7 meters? First off, you have to know decagon is how many sides? 10. Oh, sorry, somebody's got their phone on in class. Imagine that. 10 times the number of sides, it has a perimeter of 27 meters. Okay? Perimeter is easy. You simply add them all up. There is a formula for the area, though. Okay? The area of a regular, it's in a box, but it is not a postulate or a theorem. A regular polygon. Okay? So it's going to say the area equals 1/2. The area A of a regular polygon is half the apothem length A and the perimeter of a regular polygon. So you're going to have 1/2 the A times P. So it's 1/2 the apothem times the perimeter. Okay? So let's go back to that hexagon. Maybe I'll go to a pentagon. That's what we'll do. That's what we had up there first. And our pentagon, we'll say, has side lengths of 6 centimeters, center here, and it will draw either a dotted line or something that gives you that length, the apothem. Okay, so most all the time they will give you the apothem. Okay, I say most because there's gonna be a time or two that they don't, but I assured you, you can find it. I will show you how to find it next. Okay, so this apothem is going to be something like 4.8. Okay? And usually it's going to be a decimal. Just going to tell you. Okay? So we would plug in 1/2 of the apothem times the perimeter. What's the perimeter? Well, how many sides? 2, 3, 4, 5 sides times 6, and we get 30. Okay? So plugging this into my calculator, I'm going to do 4.8 times 30 divided by 2. And I get 72 centimeters squared. How in the world did that work out so nice? I don't know. It just happened. Okay, so plugging that all into my calculator, I'm going to kind of go back and say this is 5 times 6 because it's the perimeter. Okay, now, what happens if they don't give us the apothem? There's only 2 cases where they might not give us the apothem. Okay, and one will be for a regular hexagon. Because a regular hexagon is very special, okay? A regular hexagon, I'm going to try to draw it. There we go. And I'm going to do side lengths of 8 meters. It's going to have a central angle here. And if I draw this, we know these 2 sides are the same, okay? Because the central angle is, or the vertices are congruent, right? So the big question is, if I drew every one of these lines, I'm going to erase them in just a second, how much can we find our central angle? Well, if I went all the way around, how many degrees did I go? You're right, 360. And how many central angles do I have? 3, 4, 5, 6. 6 because it should match the number of sides that we have. So what is 360 divided by 6? Equals 60 degrees. That's correct. 60 degrees. Now every central angle is going to be 60 degrees. We could also find each angle of our regular hexagon. Okay, we've done that. I think that was investigation 3 that we did that. And we can find a hexagon, regular, has 120 degrees each angle. Okay, now the issue is this is going to have to be the same. This is an isosceles triangle, so these 2 angles must be the same, correct? But what did I do? I cut this 120 degrees in half, right? So guess what type of triangle I have inside my regular hexagon? That's right, 60 degrees, 60 degrees, and 60 degrees. That's very special because it is a equilateral triangle. It means all the sides are the same. So now I not only know the outside is 8, I know these other 2 sides are 8 as well. Okay? So I'm going to pull this triangle out. So this is the same triangle. I'm just drawing it bigger because I need 60 degrees, and they're all 8s. Okay? Now the apothem, remember, goes from the central angle to the opposite side perpendicularly, right? So here's my central angle. I'm going to the opposite side perpendicularly. This is very special because I have an equilateral triangle that I drew a perpendicular segment to. What did I just cut this into? 30, 30, 60, 90. So we have a 30, 60, 90 special right triangle where we know now this length is 4. Can you find the height? Can you find that apothem? I'm going to put a little A there. If you forgot, we would do a squared plus 4 squared equals 8 squared. Oh, how did I know that was 4? Because we cut the total in half, okay? So if we do this, it's a squared equals 8 squared, which is 64 minus 16. I believe that is 48. A squared equals 48, so we would say A equals. And I need to write down the square root of 48. Some of you remember this fact from the third quarter, some of you may not. So I'll show you the long way. I would do the square root of 4 times the square root of 12. We know the square root of 4 is 2. Not 12. We can break it into the square root of 4 times the square root of 3. Again, the square root of 4 is 2. So we'd have 2 times the square root of 3, or the height, the apothem, is 4 root 3. That is my height, or my apothem. Okay, you can do one of two things now that you know the apothem. See, in this case, in a regular hexagon, they can just give you the side length and make you find the apothem. Okay, you're going to do the same process. Okay, then we could plug it back into our formula. A equals 1/2 the apothem times the perimeter. What's the perimeter again? How many sides? There's 6 sides times 8 units. So 6 times 8 is 48, so the perimeter is 48. And I'm plugging all this into my calculator. If I wanted an exact answer, could I give you that? Yes, you can. I just need to know what 48 times 2 is. That's what I thought. So if I wanted an exact answer, exact means leave the square roots. So I am going to reduce. 2 goes into 4 2 times. So now I have 2 times the square root of 3 times 48. What's 2 times 48? My area is simply 96 times the square root of 3 meters squared. Okay? That would be my area, and you were not given the apothem. You had to find it. The only other case is if they give you a regular triangle. Well, duh, please be able to find the area of a regular triangle. We just did right here. The only difference I would do is I wouldn't use the formula. I would simply find the height and use area of a triangle equals 1/2 base times height. Okay? I know in your book, example 4 finds the apothem. Oh, I'm like, they are so silly. That's not needed at all. Okay? So example 3 gives you another. You can work through example 3. They give you a side length of 10 to where you can find. They don't show you how to find it. You just already have to know. They talk about in the solution that it's a 30, 60, 90 triangle. Therefore, the height of the triangle, or the apothem, is 5 root 3. Okay? So you can find that. They do a survey. I think that was pretty much it. All right. I think we're done. So we're going to have some homework. Some lesson 66 problems. All right, so we're going to do the practice. You can do the practice A through E, okay? When it doesn't give you the apothem on letter C and letter D and letter E, give me exact values, okay? So we're going to do the practice. So I'm going to say give exact values for C, D, and E. Okay, you're going to do all of them. But on C, D, and E, we'll have square roots in there. Okay? And then we're simply going to do numbers 2, 3, and 4. All right. Have a great day. Have a great weekend. This is going to be the last video this week. So we're taking a quiz. Also, next week we're going to have a test, at the end of the week. We're going to kind of play along, see how I can do that on here, what we will do. But we will have a test next week, and we'll review. I'll give you a practice test and everything, so it'll probably be next Friday. So we'll go ahead and plan for that. I'll start putting it in RenWeb. But you guys are doing great. Keep going. We'll see you later. Bye.